So I'm going to start now. So today we're going to talk about Elastic Container Service and Cloud Formation and also EBS, that is Elastic Beanstalk. And probably after the session, we would have you know our next probably we can discuss about our next meetup and probably we can understand how we can um, understand um, more about approaching the exam, solution architect exam in particular. So yeah, so let me start with the session. After the session we can discuss more about it. So now I'm gonna talk about Elastic Container Service. So before we get into AWS provided Elastic ECS uh, service, let's understand what containers are. So containers are a standard unit of software that are packaged into its code and dependencies. So the application that runs, on these container services can, run these packages without, affecting the underlying environment. So basically, these containers are isolated from the underneath environment, and they are provided with isolated environment irrespective of the infrastructure or the operating system that is running on. So containers are at the abstraction of app layers. So these containers can be run in multiple on the same machine, and they share the same OS kernel with other containers, and still they are isolated in uh, all by itself. So the isolated process happens in each user space. Containers take up less space than virtual machines, and basically container images are typically like in MB's size, and they can handle more application than when you compare it to virtual machine. So let's understand what virtual machine is all about. So virtual machines are an abstraction of physical hardware. So they try to mimic the underlying hardware, right? So they are run on top of hypervisors. These hypervisors allows multiple virtual machine to run on a single machine, and virtual machine includes a full copy of operating system, and since it is containing the complete OS itself, it would occupy more space and resources as well. So since it is heavy in nature, it takes more time to boot. So the layers, as you see in this picture, it is hypervisor would be in top of your bare metal hardware, and you can install many guest operating system uh, on top of the hypervisor, and on top of this guest operating system you could add uh, different apps, uh, and each guest operating system would contain um, would by whole by itself would be a, a mini server. So it is basically like uh, many servers, many virtual servers underneath a server. So let's understand what Docker container does. So we understood what container does. So Docker container is a flavor of container. So it also packages your application and dependencies, and it eliminates version and environment incompatibilities. It provides portability to your application, wherein you can move your application from one Docker system to another Docker system, irrespective of the underlying infrastructure. So it is also secure in nature, because it isolates the application from other applications and underlying infrastructure. So basically, Docker containers, the images become containers here, and when they are run on Docker engine. So here is a Docker engine where we install images on these Docker engine, and this will spin out um, respective container. And within this container contains app, and uh, similar to this container, there can be many containers which are running in parallel on a single Docker engine. As I said, Docker container image is very small, it's lightweight, it is standalone, and it's an executable package of software that includes it. It basically includes code, runtime, system tools, system libraries, but specifically to um, the application that is running on the image, right, on the container. So um, these containers contain everything about application, and only about, I mean, the dependencies are related to the application itself and only towards application. So you might have already heard about Docker Hub. So it's basically a number one hosted repository service uh, provided by Docker for um, container services. I'm sorry, container images. So you could use this as a private repository or also public repository, where within these repositories you can push and pull container images whenever required. So you could use this repository to hook up with other um, Docker engines to refer this image through the URL and pull the image as and when you want, right? So it also has automated builds. You can automatically build container images from GitHub, and you can push them to Docker Hub. Basically, it means that you could set up a code build kind of approach, where as in when you um, push your changes into your repository, GitHub repository or Bitbucket repository, you could connect it to a hook and trigger an uh, request to push the changes to a Docker Hub. So you can also manage your repository with your team and organizations within your organization. You could also use official images which are published by Docker itself. You can also use images which are published by many other publishers, and you could also use a webhook to trigger whenever a successful push to your repository. For example, if you are uh, referring a official image, and you're using that image, and if you're not maintaining manually to set up package to update patches, what you could do is you could set up a trigger to um, update these mm, update your packages through a trigger from the webhook. So let's understand what is Elastic Container Service. So Elastic Container Service is a container offering um, provided by AWS, which is completely based on Docker. So it automates EC2 cluster management, and it automates deployment of containers across EC2 instances. It also detects failure and also has recovery capabilities. It integrates with other AWS services, and it also provides IAM security controls. There are a lot of, yes, yes. Docker Hub alternative is there. We have Elastic Container Repository for that is alternative for Docker Hub. So this is a cluster management service um, provided by Amazon AWS. Exactly. Yeah. Correct. 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 No, Amazon also has a Kubernetes offering that is called EKS. Uh, yeah. So, so it this is all about a Docker implementation. So this is the Docker implementation, but it also provides cluster management. So yeah, correct. Yes, you can. So ECS provides different two different offerings where there are two different launch types. I'll get into that, but there are two different launch types. One is Forget launch type and EC2 instance launch type. So you could use those instances. In that case, you should have to manually start those instances and select those instances when you are launching these EC2 clusters. So this is all about cluster management. On the if you want to understand in a very high level, it's all about cluster management. But you could this would help you to add EC2 instances and then launch, then add containers and tasks. But if you already have AMI built in, you could use that as well. So there are two different ways that you could do. So to understand some of the terminologies of ECS, um, there's an image. Image is basically uh, it's a package which would be converted into a container. Cluster is nothing but a logical grouping of EC2 container instances. When I say container instances, it's a regular instance which has Docker installed in it. So either you can let ECS launch a container instance, or if you already have an AMI which has um, container agent and installed within the ECS within your ECS instance, sorry, EC2 instance, then it can be used for cluster management as well. So you need to there is also something called as container instance. So the container instance is, as I told, is nothing but EC2 instance on which task runs and is part of ECS cluster. And what are tasks? Tasks are basically contains one or more containers. So basically you can think tasks as your logical service where you could create containers for web application, sorry, web server, or application server. uh, so these database server. So all the three can be three different containers within one task. So there are schedulers, and they are responsible for placing tasks on container instances. So they place it on um, your EC2 instances. A sort of container agent which will always run on EC2 container instance or EC2 instance. This would help in starting resource management, uh, and starting and stopping the tasks um, whenever whenever it receives requests from ECS. So you need to have if you are promoting a particular EC2 instance of your own, then you need to have a container agent installed in it. So there are many rules um, uh, which you need to specify, which you could use. So ECS instance role. So ECS instance role is needed for instance level permission. Um, so if you want ECS a container to access ECS, then instance role is required. And there is a task role. So this is basically uh, for individual tasks pertaining to uh, if you want more fine-grained access control, then you could use task role as well on each task within your ECS container instance. And if you're using a Fargate, then you might have to choose with task execution role. Then um, this comes by default, and with this you get ECS permission to your instances to access ECS, ECR, and CloudWatch logs, uh, all that. So instance would get that permission. So this is a very high level picture of you know a representation of components where there is a service, there is a task definition written. So this complete is a ECS which is part of one VPC. It has got many tasks within um uh, within these ECS clusters, and each ENI is attached to this task. We'll see why we need ENIs for each task. And there are situations where ENIs are attached to each task, and there are situations where ENI is not attached to the task directly. So we'll see how and what it is all about. So basically, As we said, it's a manage Docker container on a cluster. So ECS is just a Docker container in a cluster. So it has got two types of launch types. One is Fargate launch type, and another one is EC2 launch type. So if you're looking for clusters on a serverless infrastructure, that is basically Amazon ECS. If you want Amazon ECS to manage the server infrastructure, then you could choose Fargate. So Fargate will take care of patching your EC2 instances and anything related to EC2 container instance. That it can be um, upgrading the agents, container agents, and also anything related to the instance itself. Fargate would take care of it. Or else you could choose another launch type where easy to launch type where you could manage uh, the management of the EC2 instances or EC2 container instances, where probably you might need more customized AMIs uh, built, and you could use those AMIs and launch in this mode. You could also use customize AMI in Fargate mode, but only thing is Fargate. If you choose Fargate, then the computation power would be managed by or compute power allocation would be managed by AWS ECS, Amazon ECS. So you can create Amazon ECS clusters within a new or existing VPC. And after cluster is up, you could define um, task definitions, and services. Basically, this specifies the Docker container image that should be run across the clusters. The task would contain many containers all by itself, and each container could be a Docker image by itself. Right? So containers are basically created from read-only template. That's the image. Container images are basically stored in container registries. So it could be Docker Hub, or it could be uh, Elastic Container Registry. So uh, you could use either one of them to pull the container images. So images are typically built from uh, basically Docker file. So it's a plain text file that specifies all the components that are included in the container. So let's understand what task definition really means. So task definition is text file in a JSON format that actually describes more one or more containers, up to maximum of 10 containers, and it's basically a blueprint of your application. So it defines uh, a service that you are trying to build. Right? It contains different parameters of your applications. For example, if you see here, you could see the container contains an Nginx web server, and you're allocating how much memory you want, how much CPU you need, and what kind of launch type do you need, and what is a network mode, whether you want AWS VPC. There are also two other modes: host, none, and bridge mode. So basically, AWS VPC is uh, adheres to some of the you know compliance requirement provided by uh, uh, container open source container body. I don't recollect the exact body, but they have a compliance for the container services as well. So AWS VPC is this network mode is um, updated to those compliance as and when they are changed. So the examples of task definition parameters are containers to use, launch types, as I told, ports, uh, and the data volumes, etc. So let's understand task and scheduling, right? So task is the instantiation of task definition. So in task definition, you define you define your requirements, your parameters of what components should the container contains, and how many containers do you need, and all that, right? So using the task definition, you would create a task, and after you've created the task definition, basically you specify how many number of tasks that you need, right? So using the task definition, you can create two instance of task or three instance of tasks. Based on your requirement, you could spin up as many task uh, numbers as you want. So task definitions are going to stay in your account. So you could use this task definition as and when you want within the clusters to basically to bring as many tasks as possible as you need. So each task has its own isolation boundary, and as I told, it contains containers within these tasks. The containers features, whatever we talked about earlier, all applies to tasks as well. The task scheduler is responsible for placing the task within your clusters. There are several different scheduling options available. I have added those links. They are too extensive to discuss, so I've just added the link here. Please go through that if whenever time permits. So I'll just briefly run through clusters and container agent again. Clusters is basically a logical grouping of resources. So basically it means that it would contain many EC2 instances part of it, and each EC2 instance would contain ECS agent in it, whether it's a Fargate or whether you're launching through Fargate or EC2 launch type. ECS agent would be uh, installed in each EC2 container instances. So when using Fargate, as I told earlier, uh, launch type, task within your clusters, ECS manages your cluster resources. With EC2 launch type, you need to manage. So container agents runs on each infrastructure. It sends the information about information um, pertaining to your task to ECS, and it manages your um EC2 container instances. So here you can see that these ECS agent can talk to your container registry, where it can be Amazon ECR, Docker Hub, or self-hosted registry. It could talk, and it could download the container image as and when scheduling tasks is triggered. ECS agent can go and get that image and run the tasks within the Amazon ECS cluster. So just to briefly go through, so Fargate is basically a serverless offering of running containerized application. It packages applications as containers. So it would configure CPU, memory, and networking and IAM policies as well. You could scale rapidly to support tens and thousands of containers. And Fargate it only supports AWS VPC networking mode. There are other mode, as I told, bridge, host, and none. So those modes are not supported by Fargate. So whenever you are going with EC2 launch type, bridge networking mode is the default option. So you could choose to go with AWS VPC networking mode as well, but uh, bridge is provided as uh, default. With bridge mode, what you would get is basically you would get a static port for each task that we are trying to use. So we'll see that in a bit. So basically in Fargate, we would use AWS VPC networking mode, and each task has the same networking properties as EC2 instances, and the task get ENIs of their own. So once the ENIs are attached to the task, then each task would get its own private IP address, internal DNS service, optional public IP address, and security groups, and so forth. So with the main difference between Fargate and the EC2 launch type uh, is AWS VPC networking mode is the only option with Fargate. So Elastic Network Interface would be um, created for each task. If you choose to go with EC2 launch type, then you might have to choose AWS VPC networking mode, and you would get the same capability. So pricing is um, added to this Fargate approach or launch type. So they would charge somewhere around 0.05 dollar per hour, and uh, basically they would charge somewhere around 0.0127 per hour for memory per GB, and everything is per seconds billing uh, with 1 minute is minimum. So time starts from the time when image is downloaded and ends when the task is terminated. So whenever you're choosing a task definition and building it, so choose appropriate kind of launch type that you need. So there are two kinds of port mapping. One is static, and the one is dynamic. So if you're choosing, EC2 launch type, and no, you're not going with um, application load balancer, then you will have to map the ports with each task, sorry, containers. So The port to container mapping is hard coded. So if you have an image, uh, and if you want to run that image in your in EC2 container host instance, then only one container can run on that. The reason is, since the uh, you know port would be hard coded inside the image, only one port could be mapped between the host machine and the container, right? So this, it will also have limits on flexibility of how many containers can be deployed. Else, there is also another option where application load balancer can manage your um, you know con- container containers. Basically, if you want to spin up multiple containers, then you could associate the auto scaling group with application load balancer, and it provides the dynamic port mapping capability where you could map containers with dynamic ports. So how that is done is, within your application, uh, your image can have any same number of ports, but still application would a load balancer will take care of the actual host uh, port to be assigned with you know uh, map with the container ports, and as and when they go down and a new instance comes up, um, the port mapping would be handled by application load balancer. So basically, the containers would be part of a target group within the application load balancer. Application load balancer maintains the target group mapping for every container it tracks. So the new containers that are part of target group will automatically start receiving the traffic. So ECS by itself has no additional charge unless if you are choosing Fargate. You pay only for the AWS resources created to run your application. So the resource could be the minimum resource could have like EC2 instances, storage volumes, um, application load balancer, uh, and other resources if you're using NAT gateway, and many other resources like uh, static IP addresses and many other. So there are many resources which could be used by ECS, and all those resources would be charged, but not the ECS cluster management service itself. So here is an architecture diagram of automatic service scaling. So we have two tasks, task A, task B in one of the availability zones, and task C and another availability zone, and it is maintained by application load balancer. If there are any challenges, or if the CPU utilization is more and there is a need for you have you have configured for more tasks to be deployed, if uh, this for a particular metrics, then what you could do is, what would happen is the task would send the ECS service would send uh, a request to CloudWatch, and it would update the metrics, and the CloudWatch event would trigger a task related scheduler tasks for spin up to new instances, new tasks basically. So here in these ECS service, there would be a container agents which would monitor all of these metrics or the resource utilization and most of it. So it would be pushing all that information into CloudWatch. Here is another example of microservice architecture on ECS. So it is at a very high level. We already saw that there could not be just one ECS cluster, but there could be many ECS cluster which could be load balanced uh, by an application load balancer, and both clusters could be communicating with RDS, and it is always protected by IAM security and IAM policies. You could communicate with ECR and CloudWatch as well. So I have added a link for you to see how we could launch this microservice, deploy microservice. I'll just take you there. Probably I'll show you this. This is a referential architecture. So you could just click on this launch stack, and this would deploy. Basically, this would create a CloudFormation template, and using CloudFormation template, you could create this architecture or you know resources which is similar to this architecture, and find out how it communicates and how it works. So you could use you could launch from any regions. This is a um, very good example for studying ECS, to understand ECS. So every time you create the cluster management service is backed by CloudFormation. So every time you create a cluster, it is triggered by a CloudFormation template. Oh, there is also a workshop link which I wanted to share with you. So this would help you build application which has front-end Rails app and Node.js backend or Crystal backend API. And also, this is a very simple application, but this will help you to understand the components of ECS and how the workflow happens. And it is just a basic level application to understand ECS, but it's a good place to start. So please check this out as well. So let's move to cloud formations. Um, as I told, cloud formation is infrastructure as a code. So earlier we were in our previous sessions we were discussing about one or two instances where uh, we had spoken about cloud formation probably. So cloud formation is if you want to understand at a very high level, you could see cloud formation as there are three main components. The first thing is a template. So you need to define this you know template with there are two options basically, JSON and YAML format. This to understand at a very high level, I've just you know added JSON format file. Probably next slide we'll see what are we can go more in depth about the actual flow, but mainly there are three um, components. One is template, JSON formatted file template, which contains parameters, resource creation, and configurations. Using this template, we would define the template and provide it to CloudFormation service, where this CloudFormation service creates stacks, and uh, it could also update stack, and in case of error detection within the creation or updation, it would roll back. So once the stack is created, and this stack would create actual services within AWS. So this stack is customizable nature. So let's see how, um, and let's see how what all are there in actuals of CloudFormation. So in CloudFormation, there are, as we talked about it, right? So it has got template, CloudFormation, and stacks. But over a period of time, they have added more capabilities. So earlier it was just JSON compatible, but now they have made it YAML and JSON compatible. And now they have also bought something called a SAM and macros, where SAM is a serverless application model. It's a template definition where uh, you could create serverless components. Macros are basically, um, it's functions, intrinsic functions that you could write, or custom, you could say custom functions that you could add it to your template. So you could write, this CloudFormation template, or you could use tools which are available around to help you um, get the CloudFormation template, or uh, there are a lot of sample templates also available, which are part of the blueprints of CloudFormation service. You could go and check it out as well. So once you define this template and you upload this via uh, you know browser console, or if you already have placed in S3 bucket, you could select the S3 bucket option. And once you yeah so once you select S3 bucket option, or you once you upload a file, um, what you sorry CloudFormation service would create stacks out of this file, right? So that would also create, if you have configured in a way that you need stack sets, then it would create stack sets as well. So the stack sets are nothing but stacks across accounts. So if you want to create stacks um, across accounts or regions, then you would use something called as stack sets. So once it is done, once you create a stack, then stacks would create resources. So this is a very high level, anatomy of template. You would get template format version. You would get description, where you describe what this template is all about. You could add metadata, which is just the additional information about these templates. You could add parameters. So these parameters are basically, you specify what values to be passed when the template is run by CloudFormation. So you could specify default parameters, and you could also ask for the value when this template is uh, running. So there is also a mapping option where you could use this mapping section to look up this section and find the values for respective keys. So you could also add conditions to control resources during stack creation or updation. So there is also a transform key where you could specify whether this is a serverless application or not. So you could resources are the only key that is required. So this would set the resources that needs to be created within the uh, stack. So you also have outputs. Outputs are the values that are returned when the whole stack is instantiated and the uh, when the stack instantiation completes. So to give you an example, if you want um, if you're triggering, let's say if you're triggering a cloud formation template, and by end of the creation of the stack you need to know the uh, let's say db2 instances or database instance url endpoint. So you could use that as part of output section. So outputs are required for uh, other services which are dependent on these uh, templates or after the creation of this template. So if you want to know more, I've just added a link. You could just go and check it out. There are more informations about template sections. So when it comes to parameter, if you look at this, we have in this example we have set instant type, and the default is t2 small, and these are the allowed values. So when you add allowed values, the user who is creating the stack, um, he would get a drop down to, if you are in a management console, he would get a drop down to select only from these three options. Or if you are from CLI, you would get um, one, two, three options to select. So this also contains a resource block where it says I need a resource which is of type T2 small, and there is also another resource called, this is a cloud formation resource. It's a wait condition handle. So there you could add more resources to this, and if you see this, these resource names are um, defined by you. So you could add any name as you want, but uh, the type, properties, and instant type are fixed, right? So you, in the resources, you would get logical id, which is you define it, and resource type and set properties. If you come to parameters, again you would have a logical id and data type and parameter property. So let's see what is logical id in a bit. So as I said, parameters is basically you could set values passed to the template. So you could do that by adding allow values. So when it comes to mapping is basically, as I told, would contain map id, key id, and value. So whenever you need a value 01, then you might have to go in this order to select the map. So here, let's see how we have done that. So output basically contains logical ID and some description, value to return, and also an export value. So let's see what export is in a bit. But uh, export, remember that export comes under outputs. So when it comes to mapping, region map is a popular mapping because you could select resources based on the region. So you could say uh, in practicality or in certain situations, customers, AWS customers, what they do is they would select regions for their deployment environments or their environments. For example, production and dev. Let's say they use US East 1 or West 2 for the production environment, and any other region for production and testing sorry, development and testing environments. So in those cases, it's very important to configure the region map where you set for production. There would be different values, and for development and testing there would be a different set of values. So as I said, RESTful output can declare exports that can be um basically exports can be used to reference across stacks. So let's see what that is. So intrinsic functions are basically built-in functions, and they are not part of JSON or YAML. So these functions are intrinsic functions are not available until runtime. So during runtime, the values or the functions are evaluated, and you can create your own intrinsic function using macros. So here is an link for uh, creating that, a user guide for creating your macros. So these are very common intrinsic functions. So the first is ref. This returns specific value of the resource, and you could get value from a resource in the template. So this is within the template, and this is mainly find in map is mainly used to uh, get the value from the mapping section. Sub is mainly used to replace, basically sub is a short form of substitute, so it's basically used to replace certain values within your templates. It could be a reference or um, get attribute. And there is also a join parameter, join function, which joins two values using a delimiter. So there are certain conditions. Uh, these are pretty common conditions that we know. So I'm not going to go through all of them. So equals if and or and not. So these are the conditions which are provided in intrinsic functions. Interestingly, there is something called as pseudo parameters. So these parameters exist across all templates. So this is defined and managed by AWS CloudFormation. service itself, and these are referenced just like regular parameters, but the values are managed by values, and also definitions are managed by CloudFormation. Here's an example for it. So as you can see, AWS region and AWS account ID are perfect examples of it. Basically, any parameter that starts with AWS is a pseudo parameter. Here is some more examples of them. The most commonly used are account ID, region, stack IDs. If you are adding as part of output section, and you are linking it with other stacks, then you might need this, and you might also use URL suffix. So to understand the stack itself, there are two things that we need to always think about. So one is, we need to break these stacks in layers, right? So when we see layers, what are those layers? When it comes to security and identity, we could create a stack for it. And when it comes to network or monitoring or backend services, you could create separate stacks for each one of them. And these are and again stateful services, front end services. So you could break the stacks by layers, and also you could reuse the stacks to create based on the environment. So you could use the stacks to create dev, testing stage, and prod, and you could build the environment or infrastructure based on um, different stacks and life cycles. So basically what it means is you have different stacks for each layers, and all as a whole is used to bring up different environments. So here we back again. So earlier I spoke about exports. Export is nothing but a value. It would be a unique name that is defined by the stack itself. So till the stack exists, this name would be unique, and that name can be referenced by other stacks. So if you have multiple stacks and you would have created, in this example, I have created a data lake bucket and I have named S3 data lake bucket. So in another stack, we are calling this value, we are importing the value of this bucket inside the stack. So you could always reference it using import value and exporting it from the source stack. To summarize the cloud formations, they are, you know, basically infrastructure as a code service. You could use a good editor to leverage the code templates, editing, and linting. There are a lot of plugins out there which would help you to you know help in validating your templates without even submitting into the AWS CloudFormation. So it is good to know all the parts of the template anatomy, and you should know your intrinsic functions. You could use pseudo parameters instead of hard coding it, and keep your stack small and modular so that you could import and export um, between different layers. That is all from for cloud formation for now. So let's understand something about Beanstalk, Elastic Beanstalk. So Elastic Beanstalk is basically a platform as a service uh, provided by AWS. It provides automatic provisioning of infrastructure and software. It provides pre-configured load balancing, auto scaling, things like that. It would provide full control of your underlying resource as well. And most importantly, Elastic Beanstalk again is a free service, but any resource that is created as part of this service is chargeable. Language supported, it supports many languages, and it also supports different container types if you want to launch containers within the Elastic Beanstalk. So you might be wondering, when we have something like cloud formation, why do we need Elastic Beanstalk, right? So cloud formation is basically, it would give you the building blocks, and you might have to build the whole resource, and you might have to manage it, right? You need to author the JSON template file, and application deployment is not very straightforward in that. When it comes to Elastic Beanstalk, most of the configurations and other resource management is taken care by Elastic Beanstalk. You just have to specify your application, and you could choose the different modes of application services that are provided by AWS. So you don't need to manage any of the other services which are um, integrated with the Elastic Beanstalk. So this is very pretty straightforward whenever you're starting uh, from scratch, or you want some quick way of deploying your solution into AWS. So there is also another option of Opworks, which is a powerful solution as well, but it needs scripting knowledge in Ruby, and it provides similar complete application lifecycle for resource provisioning, management, deployment, monitoring, and access control. Opworks is very similar to CloudFormation, but it has its own um, syntax and language of its own. So basically, Ruby is used for scripting. So compared to these three operations, Beanstalk is a pretty easy solution, um, and this is basically if you are starting up and if you want a quick way of deploying your web applications which are out there, you could use this. So some of the concepts, I'll just go through some of the concepts of Elastic Beanstalk. Right? So So basically, application means in this logical collection of Beanstalk components. Uh, it could be EC2 instance, it could be load balancer, security groups. Everything would come under uh, application components, application, and any change that you make would be labeled with new version. And environment is basically a resource provision to run a single application version is environment. And there are two different types of environment that you could choose. That is, one is a web server environment, other one is worker environment. If you are looking for batch processing kind of workload, then you could choose worker environment, where the request is stored in SQS, and the at the later point of time you could pull, or you could your application could um, pull from SQS and cater to the messages which are being pushed into SQS. So environment configurations are basically collections of parameters and settings to manage the resource, and configuration template is starting point of creating a new environment configuration. So you need to use a configuration template to create environment configurations. Here's a simple workflow. You create application, you upload um, a version to it, and it goes through launch environment, and again the when you deploy it, it goes into managed environment, and a new updated environment version is updated. It's a pretty a simple workflow. So I hope you already know blue and green deployments, but I'll just explain in a line. So basically, blue green deployments are like two environments which are old and new, which are basically transitioning from old uh, version to a new version, where old version would be basically blue version and the new version is called green version. And slowly we move all the traffic or um, requests to the new version, that is green deployment. So when green deployment in ECS, in Elastic Beanstalk, when green deployment is successful, simply they swap the CNAME of the two different environments using uh, swap environment URLs option. So uh, green now becomes the new blue production environment. So there are two environments which you could you know which you could use. So old environment will still be catering to the needs of the request, and you bring the green environment, you test it. Once you feel the green environment is ready to be replaced with the older version, then you could just go and swap the environment URLs. So there is also a link app which I've added to how to eliminate downtime using blue-green deployments. There are many deployment options provided by EBS. So options are like all at once, all instances are updated at the same time. There is also rolling options where each instances is replaced by one, and it is updated. There is also rolling with additional batches. This is something like uh, the existing system is not affected, but you add one instance first, um, or you add the instances which are um, uh, parallel to the existing instance, and you remove the instances one by one. There is also a immutable deployment option. So this is something like you don't update you don't do any updation for the existing instances, but you just replace uh, the full set of new instances for the older version. Yeah, this was a quick and short session this time. So um, I think I have captured most of it, and I was hoping we could, you know, discuss more about solution architect exam, and we could talk more about other things as well.